Wasteland Coder here again, and today we're going to take a look at some Arduino code. Well, actually it's a particle. Photon is the board that I have code, but they both use Arduino and particle. Both boards both use the same language underneath. And so we're going to take a look at some code here for taking some temperature readings in one of our rooms. So if you're not familiar with Arduino code, they all have this setup method which runs once when the board starts, and then a loop method which runs continuously in a loop, obviously. And so to dig into this, split it into two chunks, kind of the setup code first, and then the loop as the meat of the program second. So first, this include statement is just to pull in a library for a DHT sensor, which is this type of sensor that I have for taking humidity and temperature. It's a type 11, so we set up this DHT type as this DHT 11. It's on pin D0. And then set up the DHT library with this call here, passing the sensor pin and the type. And then I set up some variables. This report threshold will come in later, just initializing other variables, and setting up a serial log handler just for some debug statements for testing this thing out locally before deploying it in the real world. And then we get into the setup call. I set up begin serial for the serial log handler, and just for logging, have some trace statements. We call begin for the DHT sensor, and then we set up a variable in particle. So particle is made for IoT, Internet of Things devices, and so they have nice ways of declaring variables and functions and publishing events to their web portal, and they have a CLI tool and all kinds of things built around managing and your IoT devices and everything like that. So I chose that for this type of application because it has a nice way of connecting to the internet and publishing events and everything, which is just what I wanted for this type of problem. And so in the loop, what we do is I have this big if statement around the whole thing, which basically is to guard against taking too many samples per second. The loop will run multiple times per second, and I didn't want thousands of temperature readings every second. I just needed one, a minute, if that, really. And the temperature sensor itself that I'm using will actually only take a new reading every 2 seconds anyway, so it doesn't make sense to sample any quicker than that. But that's what this if statement is guarding against, and this is how we set up for taking a reading every minute. In this case, just take basically the current time plus 60 milliseconds, which 60 seconds, 1 minute. So we'll actually only do real work in the loop once a minute. So we grab the current temperature reading. This is the variable that we set up in the setup code for the particle variable, this temp f variable here. Call it just temp in the particle land. And so this value will be available in the web portal if we care to go look at it at any time. Do some just debug statements. If that temperature reading was not a real number, or if it's an impossibly negative number, it was an invalid reading, so just skip it and break out of this iteration. We'll try again in the next minute. And then here I wanted to do some smoothing, averaging of the temperature, because when testing the sensor I was seeing just bouncing temperature readings. Like one time it'll read 70, the next time it'll read 63 or something like that, which the temperature wasn't actually bouncing like that. It was something going on with the sensor itself. Since actually putting this out in the real world, I didn't really see that, but it doesn't hurt to have the code in here anyway to smooth that out. Just something to take note of, I suppose. So we keep that in the current index and then increase the index. So then if the index is 5, which it's a 0-based index, so we have filled up positions 0 through 4, so we have 5 elements in the array. We'll go into the actual reporting of that. And so this, we're just looping over each of the temperature readings in there and taking the average and then resetting index back to 0 for the next time it goes around. And then here is where I didn't want to report each temperature reading because quite often it may not change, and so I just wanted to report kind of the interesting temperature changes. And so I check against this report threshold, which was set up at the beginning to be 1.5 degrees here. I could have set this up as a particle variable, and you could perhaps created a function to change it and everything, but I didn't really care that much about it. I thought 1.5 degree was perfectly fine. So if the average that we just took is less than the last reported temperature that I published, minus that report threshold, or if the new average is greater than the last reported plus the threshold, we'll go ahead and report it. Otherwise, just continue on, because it's not an interesting enough temperature change to report. And then at that time, if we are going to report, just grab the humidity as well, just as an extra thing to publish. And we build up a statement to publish the event. So we're going to grab the temperature, format it to 2 decimal places, grab the humidity, format that to 2 decimal places, and publish that on the particle web portal. And then store that new average store that temperature as the last reported. Notice that I take temp F rather than average here. That's just a mistake. It really should be average in both here and here. I'll have to go fix that. Anyway, that's the code for taking a look at temperature readings. Like the video, subscribe. See you next time.